Good morning. Welcome to today's revision class. We're looking at qualitative analysis today as we move closer to your examination. We'll be working five qualitative analysis questions based on past CSEC chemistry papers. Most of them are actually January papers. So as we work through the questions, remember to type your answers in the chat and I will discuss whether your answers are correct or what modifications, if any, needed. So we have a first question here. It tells us here to complete the table by writing the observations for the test carried out on salt S. So just take a minute, read through the tests and the inferences and tell me what will be the observations. All right, so for the first inference here, it says here that an acidic gas is produced when we heat salt S. Normally, you have to give the observation, not the inference. The inferences are already given. So you have to give the observation. So if we heat a gas and we place moist red and blue litmus paper at the mouth of the test tube, by making an inference that an acidic gas is produced, then our observation should be based on the litmus paper. So for the observation for the first one there, we are expected to see that a gas is produced which turned blue litmus to red. So from this observation, then we can conclude or make an inference that indeed an acidic gas is produced. The second inference there is that nitrate ions are present. So if nitrate ions are present, then we know that more likely nitrogen dioxide gas is produced. So the observation there is going to be that a brown gas is produced. All right, so that would be the observation for the first test. The second test there is that to an aqueous solution of the salt S, aqueous sodium hydroxide is added gradually until in excess. And the inference that we're making there is that zinc 2 plus ions are present. So for the observations, first we'll have to talk about what is the color of the precipitate, and then what happens to the precipitate in excess sodium hydroxide. All right, good. So let me just go that through. So the first observation here is going to be that we have a white precipitate. All right, good. So I see some of you get that. So white precipitate, and what happens to it in excess if zinc ions are present? Good. So that's correct. That the precipitate is soluble in excess. In excess sodium hydroxide. All right, yes, correct also that the precipitate dissolves in excess sodium hydroxide. That is correct also. Good. So that actually this year is just 1 year paper. It was just these two parts. Some years you can have probably 5, 6 parts. Some years like this paper here, it just carry 2 parts. So we go to the second question that we're looking at today. So it tells us here complete table 2, that's the table below, to show the observations and inferences from tests carried out on a solution M. So the first test is that we're adding aqueous sodium hydroxide until an excess. So again, the inference is given, and we're asked to write down what is the observation. So if the inference is that we have either aluminum 3 plus, lead 2 plus, zinc 2 plus, or calcium 2 plus present, then yes, that's correct. That the observation is that we have white precipitate. Good. What happens to it in excess now? Now, from the inference, we can see that we can conclude that it is either aluminum 3 plus, lead 2 plus, or zinc 2 plus ions possibly present. So correct, that is going to be that precipitate is soluble in excess. All right, so this one was similar to the last question here. Continuing with the same question. This time you're given the observation and you're asked to find the inference. That's for the second test. It says here that to a second portion of that same solution M, we add aqueous ammonia until an excess. Observation, white precipitate form. So what is going to be the inference? All right, so it is going to be either that aluminum 3 plus, zinc 2 plus, or lead 2 plus ions are present. Remember to add your charges also, right? Do not just write the name of the metal, because it is not that the metal is present, it's that the ions, these ions here, are present. So whenever we're adding sodium hydroxide solution, we're adding ammonia solution there, we're actually testing for cations, right? That's just a quick way to remember it. So the question continues that an observation is made where precipitate is soluble in excess. So if it is soluble in excess, then we can eliminate the aluminum 3 plus and lead 2 plus and conclude that we have zinc 2 plus present. It says here to a third portion of M, we add aqueous sodium iodide. Now, whenever we're adding sodium iodide, or it can also be potassium iodide, and we see a yellow precipitate form, right away we know that, so you know whether the ion present or that inference there is lead 2 plus. And the question asks us to include an ionic equation. And that normally happens whenever we are asked about this one test here, that once lead is present, you're asked to write the ionic equation. So it is going to be Pb2 plus aqueous plus 2 iodide ions aqueous to form PbI2 solid. So the PbI2 solid is that yellow precipitate that you'll be seeing there. Please note here that once you're writing an ionic equation, you must have your state symbols. Good, so the question continues. It says here now, to a fourth portion of the filtrate, we're adding aqueous silver nitrate followed by aqueous ammonia. So this test here, when we add silver nitrate followed by ammonia, we're testing for the presence of the halides. So the observation is that we have no observable change. So let me know what you think is going to be the inference there. Reminder again that we are testing for the halides and we are not seeing any change. So what can we conclude? Good, so correct, that's all, with no halide present. Or we can also say, you know what, that chloride bromide and iodide ions are absent or not present. Good, so that is going to wrap up the second question. We go on to the third question. This third question is taken from the January 2014 paper. I should have mentioned the second one was based on the 2015 January, and the first one was based on 2011 June. So this third question here, this is just all that came for the qualitative analysis section of the question one. So it tells us here that we have a compound X. We carried out a few tests. And the first test is that the sample of X was heated in a dry test tube. Observation is that a brown gas is evolved, which turns damp blue litmus red, but does not bleach it. So what is the inference? And for 1 mark only. So there are some possible, different possible answers. So any one of those answers there will give you that 1 mark. So correct, you can see that, I'm just going to write through as I read through the chat there, that nitrogen gas is produced. Nitrogen gas produced. Note here that because it is it changes blue to red, it is telling us that that's an acidic gas. All right, so we could have said also that an acidic gas produced. And because we know that it's a nitrogen dioxide gas being produced there, we can also have said that, you know what, the nitrate ions are present. Because from the nitrate ions, we get in the nitrogen dioxide gas. All right, so any one of those 3 responses there will give you 1 mark. The next part here tells us now that to a portion of a solution of X, aqueous sodium hydroxide was added dropwise until in excess and then heated. The observation is that no precipitate is formed. However, upon heating, a pungent gas evolves, which turns moist red litmus blue. So once we see in there that there is a gas that turns moist red litmus blue, it is telling us it's an alkaline gas. And I'm certain you can recall from fourth form that only one alkaline gas that you will be meeting up in your study of chemistry, right, at the CSEC level. And correct, that is ammonia gas. So I can probably just make a little note here. You don't have, that's not the answer I'm writing, right? I'm just to remind you or to guide you into your answer. So the question is asking us that they don't want you to write which gas is produced, but what they want you to do is to write the ionic equation for what is happening. So what is happening there is that we have ammonium from the salt really, which is an ammonium salt, plus the hydroxide ion from the sodium hydroxide to produce ammonia gas and water. All right, so this will be the ionic equation for what is happening. If you can recall, there was an experiment that you will have to carry out when you were studying acid, bases, and salts, where you investigated the reaction of ammonium salts with bases. All right, and from that reaction there, we could have concluded that ammonia gas is produced. So this question is also based on that concept. All right, any questions on this? So the three questions so far. All right, to see no, so we go on. So we go to question 4. So question 4 tells us that a student carried out the following tests on a pale blue solution of compound X. You are to complete the table by filling in the expected observations. So they give you the inferences again, and you're asked to complete the observation section of the table. So the first test is that we add sodium hydroxide dropwise and then in excess. And our inference is that we have iron 2 plus ions present. So you have to ensure that you're not confusing the iron 2 plus and the iron 3 plus ions, all right? Because later on in the question, they'll be talking about iron 3 plus. So iron 2 plus, that's Fe2 plus. The observation there is that we're going to have a dirty green precipitate. That's when we add sodium hydroxide dropwise. Now, when we add sodium hydroxide in excess, what is going to happen is that the precipitate is insoluble in excess. All right, so these would have been the two observations. First of all, that we have a dirty green precipitate forming, and then we have that the precipitate is insoluble in excess. The second test, well, not really a test, the second, well, to be, well, be considered as a test. Let's work with that. That the resultant mixture from 1, that's the previous part here, was left to stand in air. The observation is that the Fe2 plus ions were oxidized to Fe3 plus ions. So what will be the observational? So remember that from part 2, it was the Fe2 plus ions will have caused the precipitate to be green. So let's work with it. So it was from green, and it is going to change to. So if it's changing to Fe3 plus ions, what is the color for the Fe3 plus ions? Good. So this is now it is going to be that red brown to brown color. All right. So precipitate changes from green to brown. Or you could have said dirty green to red brown also, right? And that's another option. The third test, aqueous barium nitrate was added. And then we follow it by adding dilute nitric acid. The inference for this test is that we can conclude that sulfate ions are present. So for when we add barium nitrate, what will be the observation? All right, so I'll also say that it's white precipitate, you're correct. So we'll have a white precipitate forming. And when we add the dilute nitric acid, the precipitate will be insoluble. All right, so that is it for this fourth question here. We go on to the fifth question. So it tells us here that in an experiment, a student or a group of students was given an unknown solid B and asked to identify it. They perform a series of tests and made some observations which are recorded in the table that follows. You are to complete the table by writing the inferences. And I'm certain by now you're recognizing that some years they can ask you to write what are the observations based on the test and inference, or they can ask you to write inferences based on the observations and the tests, or they can give you a mixture of it. Some parts you have to write in the observation, and some part you'll have to write in the inference. So this one question here, particular question you're working out, you're given the observation and the test, and you're asked to write the inferences. So for the first part here, it tells us that we place a small portion of this unknown solid B in a test tube. We heat strongly using a Bunsen flame. The observation is that a reddish brown gas evolved. So for 1 mark, there are again some possible answers, different possible answers. So you tell me what is your answer, and then we'll go through if you have one of those correct responses or expected answers. All right, so one force answer, then again working through from the chat what answers you're given. So one correct answer can be that nitrogen gas evolved. That gas there that evolved is nitrogen gas. From that same point there, we can say that because nitrogen gases evolved, it could have been a nitrate ion we're talking about here. So nitrate ion is present. And note here that there's another gas that is reddish brown, all right, in color, and that is bromine gas. So this here could have been also bromine gas evolved. So based on the observation there, any of these three answers, they will have given you that 1 mark. All right, so for the second test, it is basically that the students dissolve this unknown solid B in 10 cm cube of distilled water stir filter. We collect the filtrate and divide it into 3 equal portions and carry out 3 other tests. So for number 3, we see that the first portion of the filtrate, to that portion rather, sodium hydroxide solution was added slowly and then in excess. So first of all, they get a white precipitate form, and then we'll notice that that white precipitate is solid in excess. So once we're adding sodium hydroxide and we have a white precipitate, then we should recall that it can be a possible of 4 different ions, and those ions are aluminum 3 plus, lead 2 plus, zinc 2 plus, and calcium 2 plus. All right, when it is soluble in excess, then we can eliminate the calcium. So we can see here what you know, that it's either aluminum 3 plus, lead 2 plus, or zinc 2 plus ions present. If it was insoluble, on the other hand, then we could have just made one inference there, that one ion rather is present, which would have been the calcium 2 plus ion. It says here now, to the second portion of the filtrate, we're adding aqueous ammonia. Slowly until in excess, we see that there is a white precipitate formed, and again, that white precipitate, and then this time though, the precipitate is insoluble in excess. So when we're adding ammonia, aqueous ammonia, if we have a white precipitate, this time it's either of three ions, namely lead 2 plus, zinc 2 plus, or aluminum 3 plus. If that is insoluble in excess, then it is either lead 2 plus or aluminum 3 plus. So once we have either lead or aluminum ions present, our next test, and you'll notice that from most of the papers here and from experiments being done in school, that what we will do is that we'll add either potassium iodide next or sodium iodide. I mentioned that just now. A yellow precipitate will confirm that it is lead 2 plus ions present. And if we do not have that yellow precipitate, then we'll conclude that it is the aluminum 3 plus. So number 5 here tells us that a yellow precipitate was formed, so we can conclude that it is the lead 2 plus ions present. And the ionic equation, we went through that just now, an earlier question. So this is Pb2 plus aqueous plus 2 iodide aqueous to form PbI2 solid. All right, so that will bring an end to this revision session I promise you on qualitative analysis. Note here that for this question that I just worked, the last question, this one here was worth 8 out of the 25 marks for question 1, whereas some papers it will probably just worth 3 marks out of the 25. So again, depending on whichever year you're writing, you may have a different score, maximum score that is for the qualitative analysis question. All right, any questions before I wrap up? Or close out the class rather. All right, so all right, so no questions there. So enjoy the rest of the day. Enjoy the weekend, stay safe, and study hard for your upcoming exams. So until the next day, we're meeting on Tuesday for lessons. Until Tuesday, stay safe.